Welcome. The topic we'll be discussing in this lecture will be the continuation of what we discussed in the last lecture. So basically we are discussing about subroutines. So in the last lecture we have discussed when a subroutine is getting called, how the call and the return happens through through the registers, right? So one of the primary register which will play a role here is link register. Okay, so if there is no call, okay, if there is no call for subroutine, in that case the next instruction to be executed will be 204 in this particular diagram, right? And as you know that whenever the current instruction is getting executed, the PC will be updated with the next instruction. So when this instruction is getting executed, PC will get updated to 204. Okay, but when the instruction is completely decoded, then the compiler or the assembler will understand that this is a call to a subroutine, so the control should transfer to the address 1000. So that means that now PC will not be 204, rather PC will be 1000. That doesn't mean that we can ignore this 204. We cannot ignore, because after executing the subroutine finally, after finishing executing the subroutine, it should return back to this memory location 204. Okay, that is, when the return instruction in the subroutine is executed, we should come back to the location 204. So whatever the address that is available in PC, that is 204, which is available in the program counter, that will be moved to the link register. Okay, and whatever the location where the control should be transferred, that will be moved to the program counter. Okay, and in the subroutine, finally when the subroutine finished executing, finally when it executes the return statement, the content of the link register will be taken. What is that? 204, and there the control will be transferred. Okay, so this is how the call and return to the subroutine is managed. Fine. Okay, now in this lecture what we are going to discuss in the sense, so this is the case if there is only one call. Okay, if there is only one call, but if there is a nested subroutine call, then how it will be handled? Say there is the main function. The main function is calling subroutine 1, and subroutine 1 is in turn calling subroutine 2. Then our subroutine 2 is again calling subroutine 3. So when there is a nested subroutine call, how things will be handled, that we will be discussing. Okay, and before that we will be discussing like how to pass parameters to a subroutine. See, normally in functions, when you write a C program or a Java program or a Python program, we pass parameters from one function to another function. Okay, similarly in a subroutine, how can we pass parameters, right? So subroutines are basically, we are writing in assembly language. So here how could we pass parameters? Okay, right? So the answer for both the questions, that is how we will handle nested subroutine calls and how we will pass parameters for the subroutine, the answer for both the question is same. It is by using stacks. Okay, how we are going to do in the sense by using stack. If the calling program want to send some parameters to the called subroutine, then what it will do in the sense, it will just push the parameters into the stack before calling. Okay, and then it will call, right? And the called program can access the whatever the parameters it want, it can access it from the stack. Okay, so how it exactly happens, that is what we are going to discuss in this lecture. Okay, so first we will be discussing like how parameters are passed to the subroutine. Okay, program of subroutine, parameters passed on the stack. That is, if from the calling program, if you want to pass some parameters to the called subroutine, then it should be passed through the stack. Okay, you cannot pass directly, right? Okay, so these are some of the instructions which is used to move some of the values to the stack. Okay, say for example this instruction, move multiple R0 hyphen R2 minus SP. What does it mean? Move multiple means what? Move multiple means move multiple values. Move multiple means move multiple values. So it moves all these values. What are the values? The content of R0, the content of R1 and the content of R2. That is starting from the register R0 to R2. All its content will be moved to stack. Where it will, why it is minus SP? Currently if stack is pointing to, as we know that stack grows from higher address to lower address. If if uh, if higher address is 1000, then the lower address will be 0. Okay, it grows in this direction. Okay, if currently stack pointer is pointing to say 900, assume current stack pointer is 900. Okay, then minus of SP means, let us assume the word size as 4 bytes. Okay, that is 32 bits. Then minus of SP means what? 9000 minus 4 is 8996. Okay, so in 8996, starting from the location 8996, R0 will be stored. Okay, right? And in the previous location 8996 minus 4 is 8992, there R1 will be stored. Okay, and again in the previous location 8992 minus 4 is 8888, there R2 will be stored. Okay, like that it will be stored, right? So that is what it means, R0 hyphen R2 minus SP, right? Okay, so this is used to move multiple values. This is used to store the contents of the register R0 through R2 onto the top of the stack, right? Okay, fine. Now let us discuss with an example like how parameters are passed to a subroutine with the help of stack. Okay, so here is a, so this is a calling program, or we can say this is the main program. Okay, and this is the called subroutine. This is the called subroutine. Okay, so in the main program what we are doing, first move hash num1 minus SP. Okay, so again this is the same, this is a similar program which we have discussed, which we are discussing sometimes. So it is used to add it is used to perform sum of n numbers which are stored in memory location starting from the address num1 to num2 num3 up to num(n). Okay, these num1 num2 num3 are the addresses. Okay, where n represents the number of values, how many numbers we want to add. Okay, so what we are doing, first move hash num1 minus SP. Let us assume SP is 100, current stack pointer is 100. Okay, say, so this is the current stack pointer. Currently stack pointer is pointing to 100th location. So we say that my num1 comma minus SP. Let us assume num1 refers to the address 1000. Address refers to the address 1000. Okay, so what we do, hash num1 comma minus SP means that address, whatever the address of num1. Okay, because hash gives the immediate value, it doesn't give the content, that is moved to minus of SP. Minus of SP means 100 minus 4 is 96. Okay, so let us, throughout the discussion, let us assume the word size as 4 bytes. Okay, right? Then n, move n comma minus SP. Let us assume n represents 5 numbers we want to add. So again, now current stack pointer is, current stack top is, stack pointer is pointing to 96. Now SP is pointing here. Okay, so 96 minus 4 is what? This is yes, not 5. Okay, 96 minus 96 minus 4 is 92. So n is, say, let us assume 5 will be stored in the location 92, starting from 92 to 95, right? Then we say call list add. So call list add means what? Control should be transferred to this subroutine, but before transferring the control, it will push the return address, because after that the control should come back, right, after executing the subroutine. So the return address will be pushed here. So the return address will be pushed. Okay, so again, now after pushing the return address, okay, where SP will point, now SP will point to here, that is SP points to 88. Let us assume that also needs 4 bytes. Okay, now the control will be transferred here. Okay, right? Now this address now this instruction will execute. Move multiple R0 to R2 minus SP. So what it will do? Again it will push R0, R1, R2 into stack. It will push R0, R1, R2 into the stack. Okay, so R0 will come where? Here R0 will come, right? So R0 will come in which location? 88 minus 8 is what? 88 minus 8 is 84. In 84th, starting from 84th location, R0 will be there. Okay, and then R1. R1 will be at 84 minus 4 is 80th location. Starting from 80th location, you'll have R1. Okay, and then R2. R2 will be starting from 76th location. Okay, because it is 80 minus 4 is 76. Okay, so this will be R2. Okay, I think our calculations are correct. When the return address is being pushed, SP is, so this is now the stack pointer. Okay, so all this is now the stack pointer. Now stack pointer is pointing to 76. Okay, that is when return address is there, it is 88. So R0 88 minus 4 is 84. Okay, then 84 minus 4 is 81, 80 R1, and 80 minus 4 is 76 R2, right? Okay, then what we are doing, so this subroutine is basically to perform the addition, right? So what we are doing, move, here you are using index addressing mode, move 16 within bracket SP comma R1. What is SP? Now stack pointer is pointing to 76. 76 plus 16 is what? 76 plus 76 is pointing to R2. 76 plus 4 is R1. 76 plus 8 is R0. 76 plus 12 is return. 72 plus 16 is the value of n. Okay, this is nothing but what? N. N is equal to 5. Okay, so that n, count how many numbers you want to add, that is now moved to R1. Okay, now R1 contains 5. R1 contains 5. Okay, then 20 comma SP to R2. 20, 76 plus 20 is what? 96. That is what the starting address, that is the address of the first number, that is now moved to R2. Okay, so R2 will have what? 1000. Okay, that is moved to R2. Okay, clear R0. R0 becomes 0. R0 becomes 0. Then what we are doing, add R2 plus R0. What is R2? R2 is 1000. Okay, that is the content at the location 1000 will be added with R0. Okay, so content at location 1000. So say the content at location 1000 is some number. Say it is 1. Say it is 1. Then 1 will be added with R0. What is 1? What is R0? R0 is 0. Okay, so it will add 1 plus 0 is 0, right? So and the result will be stored in R0. Okay, so sorry, 1 plus 0 is 1. The result is stored in R0. So R0 now contains 1. Okay, then decrement R1. R1 contains what? Count. So now R1 becomes 4. Check whether it is greater than 0. Branch greater than 0, loop. Again repeat this. What should you do? Again loop is this. R2, it is post increment. So previously R2 was 1000. Now it will be incremented to 1004. It will be incremented to 1004. So 1004 contains the next value. What is that? 2. So 2 will be added with R0. Previously R0 is 1. So now it performs 1 plus 2, that is 3. Again decrement R1. It becomes 3. Check whether it is greater than 0. Yes, loop. So like that it will add. Finally the cumulative sum will be available in R0. After adding all the 5 values, R1, when you decrement, it will become 0. Then when you check branch greater than 0, it won't be greater than 0. So it will, this part won't execute. Then move R0 comma 20 comma SP. Okay, move R0 comma, what is R0? R0 is the cumulative sum of all these numbers. Okay, so if it is 1, 2, 3, 4, 5, then it is 5 plus 4, 9, 9 plus 3, 12, 12 plus 2, 14, 14 plus 1, 15. Okay, so 15, we are moving that result. The result is available in R0, that we are moving to 20 SP. Okay, so 20 SP is nothing but this location. So this location will be now now will have the sum of all the number, that is 15. Okay, right? and again what we are doing, finally we are restoring the register values. Move multiple SP plus R0 to R2. It means that whatever the values in R2, R1, it will be again brought back to the particular registers. I mean from stack. Previously we pushed into stack, no? So those those values will be again restored in those particular registers. Previously whatever R2 contains, that will now come back to R2. Previously whatever, I mean before calling the subroutine, whatever is in R1, that will come back to R1. Whatever in R0, that will also come back to R0. Okay? Then we return. So now you popped all these things. Once you pop all these things, obviously stack pointer now will come to 88. Okay, because you did move multiple, right? Move multiple means all these are moved from stack. Okay, and stack is incremented, right? So it comes down. So finally when you get pop, you get the return address. So the control will go back here, right? Control will go back to here, and after coming back here, what we are doing, move 4. After executing return instruction, now the stack pointer will point to 92, right? Because return also popped, right? When you execute return, this also popped. So stack pointer will point to 92, and then you are saying move 4 of SP comma sum. 4 of SP is nothing but our, from here 92 plus 4 is 96. That the result is what? 15. That result you are storing in the memory location sum. Okay. Again we are saying add 8 comma SP. Okay. So again when you add 8 to SP, what will happen? Whatever the original value of the now stack pointer, now stack top is this. Okay, stack top is I mean move 4 of SP comma sum means the whatever the 15 that is moved to the location sum, say somewhere in the memory, which we call it as sum, and to this location, to this sum location, this final result 15 is moved, but still where stack is pointing, SP is pointing to 92. Okay, so 92 plus 8 is what? 100. That is, this is the location where originally stack is pointing before we execute this program. So finally we restore the stack pointer to that location, right? So that is what it is doing. Okay, so basically the point here we are discussing is how parameters are passed in the stack. Okay, so here what are the parameters? If you see, num1 is a parameter, n is a parameter. These are parameters. Apart from that, we also use registers. R0 to R2 we are using. Why we are pushing that? Because before calling this subroutine, maybe this main program also may be using R0, R1 and R2. We don't know. Okay, because this is the partial code. This program also may be using R0, R1 and R2, and they may have some values. Okay, so we cannot you cannot overwrite those values. That is the reason before using R0 to R2, all these are being pushed into stack. Okay, all these values are stored in the stack. Now we are using R0, R1 and R2 as per our convenience, right? We are storing the the number of values in R1, the starting address of the first number in R0, R2, and the sum in R0. Like that we are using as per our wish. Finally, once our task is over, we are storing the result at some location in the stack. Then once the control goes back, this previous values in the R0, R1 and R2 should be retained, should be brought back. Okay, that is why this statement is executed. Okay, so this concept basically it shows like how parameters are being passed into the stack, into a subroutine effectively using stack. Okay, fine, let us stop here. In the next lecture we shall discuss about how nested subroutine calls can be effectively done using stack. Okay. Thank you.